Hi guys, in this video I'll show you how to make this ESP32-S3-MINI KiCad design. I'm very impressed by this powerful and tiny module, so I decided to make a small evaluation board. I'll go through both the schematic design and the complete PCB layout with all the details, so let's get started. The ESP32-S3-MINI testboard have the following features: an ESP32-S3-MINI with 8 MB of flash and built-in antenna, an HDC 3022 high precision temperature and humidity sensor, a quick connector, a USB-C connector for power and programming, buttons for boot and reset, a user button, a user RGB LED, a SPI bus expansion GPIO header, a pin programming header, and a power LED on the 3.3 volt rail. For the mechanical side of things, we have 4 3.2mm mounting holes, and the size of the board is only 40 by 40 millimeters, and it's a 4-layer board design. So here we are in KiCad. We have already created a project here called ESP32-S3-MINI, and the way you do it is just go up in File and then New Project. So we see we have two files here. One is called SCHEMATIC, the other one is the PCB. So we will get started doing the schematic design. And the first thing that we do when we have a blank canvas here is to define some things about the schematic. So we go into page settings, and here we can adjust different things. Normally I go for a A3 size, and the date we can just insert that here, and the revision is 1.0. The title, that's ESP32-S3-MINI Testboard. And the company, that's the name of my YouTube channel, made by Morten. I think that's it for now. And we press OK. And then we see down here, it has already been pre-filled. So the star of the project is the ESP32-S3-MINI. So we can just try and place a symbol. Press A, this is the shortcut key. And we can search for an ESP32 and S3. And we see there are different S3 models here. The one that I'm going for is the ESP32-S3-MINI. And the problem with this, the symbol here is it's not very simple to read, so I defined my own. So we can go down here. You see this is much simpler symbol. There's not so much information, and we already have the footprint defined. So let's try and place that. Place it over here. Some other parts that we would like is the temperature and humidity sensor, HDC 3022. And we can place that over here. And we would like to have a USB connector. USB _C. You can see which different ones we have. I think I go for this with the 16 pins. And we'll put it over here somewhere. That's the major parts for now. I think we will get started filling in some of the signals here on the ESP32. So what's needed here is of course the power supply. So we'll go here, place symbols or power symbols, and we would like to have a 3.3 volts net. Like that, and I like this one to be a bit closer here, like that. And we can then place a wire here. Just click on the entry, and there we have it. And I would like a few capacitors to decouple the ESP32. And that was A. And we can here in the search field just press S, and I would like the one called S_small. Like that. And I would like that to be 100 nano, or this one should be 10 micro. And I would like another one on 100 nano. And we would like to have some ground symbols on that one. Place power symbols, and that's press P. So we'll try that, P. And we would like a ground symbol. Like that. And duplicate, Control D. So now we already have the decoupling capacitors and 3.3 volts to the ESP32, and we would like to have ground as well. Like that. So this video is sponsored by PCBWay, who offer a wide range of manufacturing services for your projects, including PCBs from very low cost prototype boards to more advanced PCBs, all the way up to 60 layers, and also with specialist FR4 materials. You can also get your rigid flex PCBs made if you want to make something a little bit more interesting. They also offer a wide range of PCB assembly options. That means getting your PCBs assembled with components on both sides of the board, whether they be surface mount or through-hole parts. PCBWay also offers some mechanical services such as CNC machining, sheet metal fabrication, 3D printing, and also when you're making something with a little bit higher volume, you can also get some injection molding done here. So don't forget to visit PCBWay.com. So the enable signal along with the GPIO 0 and boot, there we need to have some buttons attached. So let's assign a button for this one. We need a pull-up resistor and a capacitor here on the input. And we would like this one to be 1 micro. And then we need a resistor, a pull-up resistor. And we call that R small. Like that. And we would like that to be 10 kilo ohm. And we would like to pull up to 3.3 volts. And you can select and then press G and then move. Like that. And then we will have the button here. And we would like a switch. And just a simple one. Like that. And we would like to connect that one to ground. that. We can make it a bit smaller. Like that. And I would like to have some ESD protection here because we are coming here with our finger. So let's try and find a symbol for that. ESD. And this one would be perfect. It's a 3.3 volt ESD diode. Like that. And we can move ground symbol over here. Like that. So this is quite simple to interface with the power and reset. Now we can add a I/O signal here for the GPIO 1 or 0. We need to also attach a programming interface for this. The ESP32-S3 can be programmed via USB or via a standard pin header via the UART. So we will add that. So we need here a signal on GPIO 0. So we will just define that and give it a net name, and we will call that place net label, that's L, and we will call that ESP IO 0 and place it right here. We have some special things about GPIO 3. We need to pull that up. I have found some different strapping pins and informations about pins we have to take care of. So I have that over here, and we can just insert that into a small text module. Place text box, and we can draw it down here and paste the text in there. So what we can see here is that we have GPIO 3 that's floating, and we need to pull that up to 3.3 volts, and we have to take care of GPIO 0, 45 and 46, and we have to take care of IO 35, 36 and 37. If we have a module where we use PSRAM, we can get the ESP32-S3-MINI in the different variants, and one of them is where you have PSRAM included, and then you cannot use those three inputs. So we will take care of those three: GPIO 0, 3, 45 and 46. So this is basically just some small reminder that we have to take care of those signals. And we'll put it here. Like that. So we'll need a pull-up resistor on GPIO 3, and we'll just use a 10K pull-up resistor. So we can just take this, Control D, and then just draw a wire here. And just remove that. And we can move the text a bit closer here, like that.
Alright. So the pins that we are not going to use, we can place a not connect pin, that we have said to ourselves, okay, we don't need to assign these nets to anything. And it was 45 and 46. We will not touch those. And GPIO 0, we need to assign a button for that circuit. So we can just take this circuitry here and duplicate that. Just go down here below, and then we would like to assign this to that nets, like that. Then we have the programming header. I normally use a 6-pin programming header, so we can use the default programmer from Espressif. So we will just place a 6-pin header. And that's under connectors. Need to remove that one. And let's find a pin header up here. Connector generic. And that should be a 2 times 3. Odd even. Like that. And here on pin number 2, we need 3.3 volts. Control duplicate. And on pin number 4 we have ground. And we have signals here and over here. Sorry. And we have IO0 here on pin number 6. And we can just take and grab it so we have the same name. Yeah, maybe we should do this in a different way. Like that. And then we need the enable signal, and that's L for label. And we'll just make them a bit longer. And then here on pin number 3 we have sorry, that was L, ESP32-S3-MINI-1-N8 like that, and label ESP-RXD. Okay, like that. And the ESP enable signal that is up here from the reset. So we can just put that up here, like that. And then we need ESP, TXD, and RXD. We need them over here. So the TXD pin is here, and I would like them to have the same length as this one. So we can just copy this, Control D, and like that. Like so. And we can just rearrange this a bit. And maybe I can have this on an A4 sheet. Let's see if that's possible. We can do that a bit later. Then we can try and see if we can fit everything into an A4 instead of A3. What else do we need? So we have an RGB LED, and we have an SPI connector, and some I2C, and some power supplies. So let's start by inserting some signals for the RGB LED. So we can try and define that one. And I would like maybe GPIO39 and (40) and 41. We can use those for controlling the LED. So we will call that L for label. So LED red. And LED green. And LED blue. So we have those three signals, and then we will find a RGB LED. Place symbol, that was A. And let's see if we can find one RGB. Sorry. I would like maybe, no, not this one. I would like one with a common node. I think this one would fit. And we can just transform this one, so we will mirror it horizontally, press X, and we will just need to have 3.3 volts here on one side. And then we'll need some resistors in series with the signals. And press R for rotate, and this should just be 1K. And rotate the designator here. And then, yeah, we can just take that away. Then duplicate this, Control D. And we could maybe move that around. Yeah. Maybe like that. Like that. And then we have the red. And then we have the green and blue. So now we have the LED, RGB LED connected with series resistors. And what else do we need? So we need a temperature and humidity sensor. And I already found this one, the HDC 3022. So let's see what we need to hook that one up. Can just move the value down here and the designator. So we have ground and VDD. So let's connect those two pins. So maybe we should, I would like to have VDD in the top, so we can just rotate it, mirror it vertically like that, and then we need to move this around. So we can take and move VDD up here, and that's 3.3 volts. Grab that from over here. And I would like a decoupling capacitor close to that. And grab it from here. Can maybe do it like this. And then it sets ground here. And then move that up here in the middle. And then we have reset is active low, so we can maybe just connect that to VDD. And the address pin, we can have a look in the datasheet. There are two address pins, address and address 1. And then of course we have an alert output, so we will not use that. So we can just place a no connect on that one. So we will have SCL. SDA, and we'll just put a label on that, L SDA, and then SCL, like that. And let's have a look in the datasheet what we should do about the address pins and the reset pin. And I have the datasheet here. And we can try and see if we can find the description of the pins. So what do they write? If not used, then just keep the alert pin floating. And reset pin active low, internal pull-up resistor to VDD. If not used, tie to VDD. So we will tie reset to VDD. And then we have address and address 1. So address 44. For device address is 41. Address 1 must be ground. And if we then put address 1 and address to ground, then it will be address 44X. So we'll just put ground wire to those. So VDD on reset. And address 1 to ground. And address also to ground. So then they have the same height. I like that. And we can bring that down a bit. And then we can write the text here. Place texts. Add C address. X44. 0x44. Like that. And we also need pull-up resistors on the SDA and SCL line, but I would also like to have a quick connector. So on that connector I'll place the pull-up resistors. And the quick connector, that's a 4-pin connector. So let's find one of those. Place symbol. And we'll remove this one. And we'll collapse all. And then we'll have a look here for a connector. Generic 1x4. So this is this one. And I would like to mirror that horizontally like that. And we know on a quick connector that pin 1 is ground. I also have a small description here. This is about the colors. And we can also place that. place text. And put it in here, and I would like to have that on the left side, like that. So we have pin number 1 is ground. And we have pin number 2, that's 3.3 volts. So we can grab that as well. Place that here. Then we have SDA on pin number 3. And SCL on pin number 4. So we can just grab those. SDA here on pin number 3. And SCL over here on pin number 4. Then we need a couple of pull-up resistors. And we will make them 4K7. Two of those. Like that. And save. Like that. So we also need one more button for a user button. The two buttons we have already, they are assigned for booting and resetting the device. So we would like just to have a user button, and we can just copy this circuitry here. And we would like to have the ESD diode along. And we can remove that later. Like that. And move this up a bit here. And then the ESD diode, and we can just use an internal pull-up resistor inside the ESP32. And for that one, we will use a user switch name, and we can put that on GPIO 48. And we will call that user switch. Switch. And we'll have it here. Duplicate it. And just put it on there. So now we also have a user switch. Alright, so the next thing that we want to install is a 3.3 volt LDO So we will have, I just inserted and remove that one. We will get 5 volts from our USB connector. So we will have to bring that down to 3.3 volts, and we will just use like a standard LDO. So I'm using the LM1117-3.3. So we can try and find that one. This is this one in a SOT 223 housing, yes. And what else do we need here? We need a ground wire, the ground connection. Like that. And we need a decoupling capacitor on the input. And we need one on the output as well. Down a bit with this. And 10 micros, that's fine. And we'll have that over here as well on the output. And we'll place power. So we have 3.3 volts on output here. And we will have our input, we'll have our 5 volts. So place power symbols. And we have one 5 volt. Down a bit. And down a bit with this text. And I think I would like an indication of the 3.3 volts. We will have a power LED. And we'll need a current limiting resistor in front. And that should just be 1K as well. And then an LED. And rotate. And which color do we want that one to be? We would like a green LED. And then some ground. Like that. Perfect. And what else do we need? So we need to attach some ESD protection on the USB lines, and we need some extra components here on the CC1 and CC2 pins. They need to be connected to a 5K1 resistor in order to supply 5 volts and a max of 1 amp. That's a configuration resistors for the USB pins. So let's place a net name here. CC1, I need capital letters. And CC2. And we need two resistors, 5K1 and duplicate that one. We can just change the value first, 5K1. And then a ground symbol. Like that. Then we have those two lines connected to ground via a 5K1 resistor. And we of course need to connect shield and ground here. Like that. Maybe do that a different way. Like that. And the type that I'm normally using for the USB-C connector, have that here as well. So we can just save and play some texts. So that I have a reminder of the part number here. These two pins, SBU 1 and 2, they are not used, so we can just place a no connect flag there. Then we have the D- and D+ for the USB signals. And we can connect them together here. And that's D-, and D+. Okay. And we of course need a ESD protection diode on those signals as well. So let's find one. And I normally use one called USB. Let's see down here. This one, USB LC6. So let's place that one here. And we need to connect that to 5 volts and to ground. Like that. And then we have the input signals here. And we have the output signals. And we have D-. We can just copy that. D+, like that. And then we need another name here on the output pins. So we will just call that USB D-. D-. And this one USB D+. And then we can copy those names, so we have the exact same ones, and we need them over here. Like that. D- and D+. And we need a 5-volt net. And we would like to have a decoupling capacitor as well. Grab it from here. Just move that name down here a bit. Like that. So what else do we need? So we need the power coming from the USB connector. And we would like to have a small fuse in series, so if something happens on our prototype board, then this fuse will open. So let's find a fuse. The polyfuse, yeah. Rotates. And this should just be 1 amp. Polyfuse. And then I would like a thread bed, a bead. This one. Rotates. And I normally use one called BLM 21PG221. It's rated for 2 amps, so that should be fine. And I would like also a series diode here as well. Like that. And place a diode. And that should be, I don't know if that's a symbol for that, 1N58117. Like that. And then we have our 5-volt net coming in here. So let's move that in a bit. And we can move that a bit. And then this one. And then our 5-volt net. Alright, so it's beginning to look like something we can use. I think we need to get some blocks arranged. I think it's possible to fit this into a smaller sheet. Let's see if that's possible. Just move this a bit closer to each other. Like that. And we can then save, let's say file, save, file, page settings. Let's go for an A4. Let's see. Yeah, I think it should be possible. So let's try and arrange things here. Like that. Power supply over here. Then we can have the LEDs underneath. And then our quick connector. Roughly like that. Then we have our user button here. Like that. And then we have our temperature and humidity sensor. Could try and place it around here. And let's try and grab all the stuff here. Try and move this a bit closer to each other. That. And then maybe we can move everything a bit closer to the edge here. Like that. I think that's fine. Let's try and divide that by drawing some lines. Yeah. So place, draw lines. We should get a bit closer, or we can try and move this a bit closer. Place line. And we can move that further away from here. Like that. I think that's fine. Oh, sorry, that's to make this a bit shorter. Like that. Then we can try and divide this as well. Place line. Like that. Then we have the LED. We can try and make a copy of this one. See if it will fit up here. And one more. Like that. And then we can divide this place line. Can always move it a bit later. Place line. Let's see, does this make sense? Can try and rearrange this a bit. Quick connector. Temperature and humidity sensor. The RGB LED. Then we have the LDO here. The user switch button. That, and then we have the USB. Can move this out a bit, like that. Alright, so what else do we do? We need the SDA and the SCL lines. So I think we can put that over here. So we'll put SDA on GPIO8 and just to have the same length. Like that. And we have SDA 8 and SCL on 9. Then we have all the signals there. So one more thing that I have on my list, I would like to have a 10-pin connector with some SPI signals. So let's try and find a 10-pin connector. Let's see if I have it down here. There's one here. And let's place it right here in this box. And let's just call it pin . Two by 5. And I can just call this as well pin 2 by 3. This is just standard pin headers, so nothing special in that. So let's connect some ground to 2 pins. And I would like to have 2 pins connected to ground, or to VCC, or 3.3 volts. Duplicate. Like that. And then we need to have some signals on. So we have 6 wires. So we will have one called, we will have a reset one label called resets. Yes, and then we have MOSI on our SPI port, MOSI, and we have MISO. And we have chip select. Then we have clock. And we would like to have an interrupt as well. Or this can also, of course, be used as just a generic I/O port. So we can grab those signals, duplicate that, and then we need to attach that to our circuitry or our ESP32 over here. Like that. So we will have the chip select signal. Can have it here. Then we can have MOSI. Then we can have clock. Then we can have MISO. And then reset and interrupt. Let me remove those lines. And then we can clean this up a bit. Like that. And maybe we should just move everything in a bit so we can have the reset. Like that. Then I think we have all GPIOs that we want to use, so we can just place no connects on the remaining ones. Then we are certain that we have all that we need. Like that. And save. And we could also put in some labels on each box here, or some text. Draw text. And we will call this USB-C. And USB-C. Like that, and maybe some larger letters. Okay, let's see how this looks. Something like that. Then we have an LDO here. And RGB LEDs. Quick connector. And temperature and humidity. Temperature and humidity sensor. And then we have some I/O. And we have a user button. And up here we have our ESP32-S3-MINI module. can maybe take that just a bit down. Like that. And then we could also place some mounting holes, the symbols for that. And mounting. Mounting, and we need 4 of those, like that. We can just put them down here. And programming header and the boot mode switch or button. Alright, I think we are getting close to have a completed schematic. We can always come back to this if we see some mistakes or we need to change some pins or signals are going to be routed on different pins, if that would be helpful. But let's save this. And the next thing that we would like to do is to make an annotation so that we have a nice view of the parts, so that they will be annotated in a horizontal way, so that they are the designators are not being mixed around in the schematic. So we go up here into Tools and Annotate Schematic. And we can select here by in the Y position or in the horizontal one or in the X position. So we will use this one and the entire schematic, yes. And then we select Annotate. Great. And close. Then it will start with C1, C2 and so on, and U1. I think this is perfect. Save. So one thing we need to do before we go into the PCB design is to assign a footprint to all the parts. So you can do that by double clicking and then go into footprint here, but it takes a long time. So it's much simpler to go to Tools and then go to Edit Symbol Fields. And then we also have a complete list here of all the footprints. And then we can just add the footprints in here. So this is much easier and faster to do. And of course we can also find the datasheets for the different parts and insert that. And we could also assign, for example, a Mauser part number in here. We could just make a separate column for that. We could just add one, for example, here, say add, and then call it Mauser. Sorry. And then we can move over here. And you see there's a column here, and then we can just enter the Mauser part numbers here for our bill of materials as well. And of course we can make an export of this and make the bill of materials, but we can do that a bit later when we have assigned the correct footprints. So let's have a look here on the ones that we already have assigned, if they make sense. I think this is fine. Some diodes. This is a through hole one. I think we should find another footprint for this one. So we would like to have an SMD one for that. And we could just find a Minimalf package for now, and a SOT80. Yeah, I think that's the one for now. And we have the SMD LED, yeah, that's fine. So let's find footprints for our 10 micro. I think that could be done in a... We can use a 0603 capacitor SMD, and we have an 0603 here. Can just take this one. Alright, so now we have all three are 0603, then we have some 100 nano, and we would just like an 0402, and our 1 micro, that could also be a 0603. Then we have a green LED, and we'll just write LED here, and we could use an 0603 LED, and this is this one, and then a polyfuse. You can just write this as a polyfuse. Maybe this is a bit too big. So we can just use fuse. Just use this. That's a 1206 package. Is that an 0805? Yes. Mounting holes. Mounting hole, and we would like that to be a 3.2 millimeter. Let's try with this one. Top and bottom. Yeah, we can do one with pads or without the pads. Can try without the pads. Then we have the USB connector, and then we have the quick connector. this one, and then the pin connectors, 2x5, and 2x3. Then we have some resistors, and they should all be 0402 ones. Then we can just highlight that, control copy, control duplicate, C, V. Switch a button. Yeah, we have two different types. So I would like to see those. I can just split them here. So I need to see in the schematic again. So user button, that's SW1. And this is this one. I need one with a side view. That one. And then I need some SMD ones. Control copy and paste. So now we have assigned all the footprints. So let's say apply, save, schematic, and continue. I think they are all there. Okay. So now we have assigned all the footprints. One thing we can do is we can generate a bill of material. So here we have a common comma separated one. So we can just say export. So now we have that written into our directory here. Okay. And what would be nice, that would be to have a PDF file of the schematic here. So we can just say file, and then plot. And then you can select different formats here, PostScript or PDF, or some images. So let's just have a PDF file and plot the current page. That's it. Then we can go into our directory here, and there we see we have a PDF file. Try and open it, and there we have a very nice color schematic. And we can hide that away. And we see here we have our comma separated bill of material file here. So now we are ready to start the PCB layout, but I think it's time for a small coffee break, and let's see you in a few seconds and do the PCB together. So now we are back again, ready to do the PCB layout of our ESP32-S3-MINI board. So let's go into PCB, double click here on PCB file, and then go to tools, and then we can update the PCB from the schematic design. And we can update the PCB. And we see here that we have 0 errors, 3 warnings, and we have some unconnected parts or pads. So this is on the quick connector, that's fine. And then we have the center pin on our temperature and humidity sensor. Pin number 9 is not connected to anything, so we just need to verify that it's okay not to connect that pin to anything. So we can verify that a bit later. So I think this is fine, so we say close. And then we have all the parts defined in our schematic with the correct footprints and so on. They have now been placed here together. Let's verify the humidity or the temperature and humidity sensor. This is this one. This was pin number 9, and we just need to verify that we can keep that pin unconnected. So we have the datasheet over here. So we have the thermal pad left unsoldered. Floating pad. So this is fine. We can leave that pin, so no worries there. So we wanted to have a PCB with a size of 40 by 40 millimeters. And let's try and make a PCB with that size. So we go to a grid size of 1 millimeter. And then we should select a layer called edge cuts. Here we define our edge. So let's make a rectangle and then make it 40 by 40 millimeters. 40 by 40. So if we are lucky, we can have all the parts in here. I think it should be possible. If we rearrange it a bit, of course. Let's take that and move it over here, and then we can drag all the parts in there as we go. So we can move our mounting holes in here. Yeah, I don't know how that would look. You can try that. In that position. And then we can round the corners. So select, and then we can go to shape modification and fillet lines. And let's try with 3 millimeters. And then we have rounded corners. That's very easy. And let's take the silk screen off the mounting holes and remove those. Like that. And the main part is of course the ESP module. So we can have the antenna on the outside here. Like that. And then we can have the USB connector here. Just in the middle. Like that. Let's try and figure out where the center is. We can add some dimensions, place, draw dimensions. So we know this is 40. Sorry. And of course I need to change the layer for this, so we can have that on user 1 layer, no, user 2 layer. Then we see the color changed. And we can try and find the middle, or we can just move the origin here. We'll also press space, then we have dx and dy, and 20, this is here. So we can just draw a line. Through here, that's the center. And we can put that also in the user 2 layer, like that. So we can see here we have exactly the center here. And for the USB connector, we need to move that a bit. Like that. Then that's centered. And if we don't want to look at these helper lines, we can just close or hide that layer, like that. That was 2 important parts. So let's fill in some of the remaining ones. We have the 10-pin connector here with all the SPI signals. We have the QWIIC connector. Let's see if that we can move it up here. For now, this is just the initial placement. And then we have the user button here. Like that. Then we have an RGB LED. And we have temperature and humidity sensor. Power supply, LDO. Then we have the ESD diode for the USB. Like that. Then we have some of the power for the LDO. And there are some parts and the fuse. That. Some of the smaller parts, they are easy to fill in, but it's important that we get the major parts placed. And this is the power LED. Be nice to have over here as well. around the LDO, and then we have the reset and boot buttons. I think that could be nice around here. Alright. Then there's a lot of text underneath here in this layer, some fabrication informations or the values. We can just hide those, but right now it's nice to have these around here, the 5K ones. Then we have 4K7, that was the ones for our pull-up resistors for IQC. Could be around there. And some decoupling capacitors. And C1 and C2, they are for the LDO. Like that. And the rest we can just move them around. Let's hide the fabrication layer. It makes it a bit more easy to work with. And we can have a look in our 3D viewer just to see how our board looks like. And then we go to View and 3D viewer. And there we have our design. Think that's fine. I think we should just start to rearrange the parts a bit and then place the smaller supporting parts as well. And we see there's one footprint here missing a 3D model. And the temperature and humidity sensor, I would like to have another 3D model for that one. So we could just try and figure that out. So the way we do that is that we just double click on the part. And then we can add another 3D model. And let's see what we have. And that was called HDC. This one. And then we should hide the other one. And then we can just flip it around. And then we should just rotate it a bit. Like that. And then we can just check that we have the correct footprint as well. Then we can offset the part. Just have a look below. So it has not been rotated the correct way. This should be pin 1 number 1. Like that. And it seems to be not the correct footprint that we have here. This seems to be too small, so I need to change the footprint. And the way that we do that is that we go back into the schematic and double click here on the part. And then we see there's this package here. and I have that in another library. I think this was this one. Could it be another library than this one? Is this one? Okay. And then press save. And then we go back to the PCB. And then we say tools, update PCB from schematic. And then we have another footprint here. And then we can have a look in our 3D viewer. I'll save this, and then we double click here again, and now we can see that it looks a bit better. Yes, now we have the correct size. Like that, and then set should be 0. Perfect. And if you want to look for 3D models and so on, then you could head over to SnapMagic or SnapEDA. And here you can see I found a symbol, a footprint, and a 3D model. And if you need some 3D models or something, then try and have a look here, and you can download that to all the step files for the 3D models, and of course the symbols and footprints for KiCad. You can download that from here and put into your own libraries. So another thing was our LED. There was a missing footprint, so we can just add one. And I have one here. Okay. And that seems to be a perfect fit there. Just okay. Let's have a look in our 3D model. And this is just the highlighted part that we have, so I think everything looks fine now. All 3D models are in there. So let's try to get started routing some of the more important things. One of the critical things is, of course, the USB wire. So I will just bring that out a bit like that. The USB signals, they are of course the most critical ones, so I think we should route those right away. So we see here D- and D+. They go directly in there, and where are these located? They're located right up there, the USB pins. So that's fairly easy to route. But of course that should be done with the correct impedance. So we'll try to do that. The way that we do that, we have to set up some things about some constraints and some design rules for our tracks, and we do that here in net classes if we have to do something special about the USB lines. So we see here a default net class, so our default clearance will be 0.0 millimeters, 0.2 millimeters of clearance, and the track width would as default be 0.2 millimeters, and the VS and all the things. But what we are interested in making a special net class for our USB signals. So we can assign a new net class for our USB signals. So let's add one new and call that USB net class. And we need to fill in here the differential pair, the width, and the gap between the signals. And in order to have a 90 ohm impedance, then we need to calculate the dimensions of the tracks. And I already started doing that here in the Saturn PCB design. There's a calculator for doing differential pairs, and this is for a USB 2, and we would like to have a value of 90 ohms, plus minus 10%. So we should have a track with an impedance of between 80 and approximately 100 ohm. And the way that I did this was just by trying to hit something that can be produced. Of course, we need to have the right the copper weight and the copper thickness, and we are in metric units. We are using a standard FR4. And what else is important? That's of course the conductor width and the spacing, the gap. So you can see if I change this to 0.1 millimeter, then the differential impedance or the differential pair will have an impedance of 82 ohms. So you just play around with it until you hit something that are very close to your preferred value. And you can see here it's green. It's because it's in between our target here. So if I make it 0.4, then we can see it's outside, it's red, and the impedance is now 108 ohm. But if I make it 0.155 millimeters in spacing or the gap, then we are very close to 90 ohm. And you can see down here other things that are important is of course the height from the ground to the conductor. And here I'll just use a conductor height of 0.2 millimeters. We could also use one of 0.1524 is also a common value. Then it's 80 ohm, and then we could see, okay, what can we do here? What if we make the width of our track also 0.15 millimeters? So if we just use 0.15 millimeters of width and gap, then we are also very close to 90 ohms. And PCBWay, they have a stack up where they have this height. You can select that height. So if we just use those two parameters in our net class, then we should have a differential pair of with an impedance of 90 ohm. So let's head over here and then say, okay, our width, that was 0.15 millimeters, and the distance between them was also 0.15 millimeters. So now we then have to assign that net class to the relevant signals, and let's try and find those USB signals. And I think we use a \USB or was it capital letters or D minus? minus. So that's this net. So we use a slash in front and then a slash d plus, and that should also be USB net class. So that's the wires from the connector, and the other ones, they are called USB underscore D minus. So let's try and add a new, and then slash USB underscore D minus. And one more, that was the USB underscore D plus. And you can also just make a star, and then you can select them from over here. That's all the nets. But we have the 4 ones, or the 4 USB tracks. Press OK. And let's save this. And then we can route the differential pair. Route differential pair. And we can go from here and then up here. But we can see that we are on a wrong grid, so we want to have a finer pitch grid. So let's use this one, and then we can try and route it. And it's sometimes it can be a bit sticky, this stuff. See, that's fine. So D plus is this one, that's fine. So we can just leave them there for now, and then we can move it so it's in the center. So we have the ground in the center there. And we can try and say route differential pair again. Like that. It's not so nice around here, so I can just try and delete this again. And then say place or route differential pair. Like that. There's still some inconsistency there, but it's very, very little. And we can take and route this one. Yeah, sometimes it's not so easy. Sometimes you have to do it just by manual routing. So we can just take it over here, place, route, single track, and then just do it like that. Like that, and then you can always adjust it, but I think this is quite good. So this is the most critical tracks That's the USB lines. And of course we can maybe just, don't want to this is very small details. Like that. I think that's fine for now. Yes. Now we are free to route, and we just need to keep some distance to these tracks. But that's not a problem. So let's see what we can do here. With power coming in from the connector, USB connector, so the first thing we meet is the fuse. So we can just move this away and we will go to a 0.1 millimeter grid. So let's see the fuse. Like that. Then we go into the third bed. And then the diode. Like that. I think this one should be rotated. Like that. And then we need to route this. Like that. And then we need to get the 5 volts from up there. I think we should just make a via here. Go to 0.5 millimeter grid. Let's try and put a via here. And also over here. Like that, and then we can select another layer. Let's go to the bottom layer. Then we can route that track. Like that. And then we can go behind. Or over here we can also go this way. Down here. Like that. We should also remember to route the USB traces here. So it would make sense to route this one over here. and then this one around there. Like that. So now we have 5 volts coming in, and we should bring that to the LDO. And we could move the LDO up a bit and then have the decoupling capacitors down below here. 3.3 volts. And the 5 volt decoupling. And then we'll have the 5 volts coming in. And we can just put a via here. And then route another via out here. And then simply drag a line between those. Like that. Then we have 3.3 volts, and we would like to go into a via here, and we would like to have this as a 4-layer board. So we will keep one layer for ground, the layer just below will be ground, and then we will have a 3.3 volt layer and then a ground layer as well in the bottom. So we can just say save here, and then we can say board setup, and we will have the physical stack up. So this will be a 4-layer board like that. Later on we will show you how to make a fill zone where we can attach different signals to different fills. But we will do that when we have completed the routing of the board. So let's have a look here. The power LED. We could have that up here. That, and we can move this a bit away from the edge. And this one as well. Let's have a look on the 3D viewer how this looks. I think that's fine. Yeah, let's go with that. And we need a resistor in front up there. So the way that we can find the correct resistor here, of course we can trace the track, but we can also go into the schematic and then we can highlight the LED that we want, or the resistor we want, and then we can go back here and then we see it's also highlighted over here, and then we can select it, and this is the correct resistor. And yep, rotate like that, and a wire, and we can just make a via to 3.3 volts here like that. So now we have the power supply, should be fine. Then we need the switch, there we need a couple of parts. The ESD protection diode, we can try and find that one. Use a button. So we highlight it here, go back to the PCB layout, and then we have the D4 here, and we can move that over here. And we can route the track, should be on the top layer. And place a VF for now. And this is just signals that we have to route to the ESP32 module. So that's also quite easy. Then we can take the programming header. There are some signals involved in that. So the programming header, we have some buttons and some parts that are required. Let's first see the R11. Where would it make sense to put that one? So that's up here. Would make sense to put it up here. Like that. And just a via there. And we have the user button, or the programming pins and boot. So we can just call that. Can we change this one to reset? And we can call this boot. Yeah, and we want the ground to be out there next to the edge. And this one as well. Like that. So we have some signals or some parts related to this ESP enable, the reset button. So this is those parts up here. And we can move those around. And then we can grab those and put them closer here. And the first part we need to hit is the ESD protection. Then we have a pull-up resistor. That. Then a capacitor. Like that. And let's see, we need to bring that signal up to the programming header. And we can just switch layer, do that on the bottom side for now. And we have it here, and then we need to go through, then up to a pin up here. And let's route this like that. That was the first signal, and let's see if the boot switch, what do we need there? That's those parts down here. Then just copy them together. Like that. See this, yeah, there's room for it. Move. Then the pull-up resistor. Capacitor. Could just rotate that a bit. Place it in parallel here. Could do that for this one as well. Then it's not on top of each other. And let's route these signals. And we will have a via here to 3.3 volts. The same goes for this one. Like that. Alright, so we are getting there. So the boot signal, we also need to bring that up to the programming connector. Let's place a via there, route it. That, and then it should go to the other side here. Just move this in a bit. Place a via. And then switch layer. Move up a bit here. Here. And again switch layer. And then we are close to where we want to be. That's it. You can drag this up a bit like that. Drag this up there. Like that, and drag this away a bit. And we see the RxD line. Just route that. And the TXT line is close by. Like that. And the ground ones, they will be automatically connected, and also the 3.3 volt line. So we have 3.3 volts up here. The main power pin on the module, that's is pin number 3, so we need those two capacitors to be close. And we can just move them away. Something with a designator. Like that. So let's place a 100 nano close by. And the 10 micro next to it. That's to 3.3 volts. And we would like them to be as wide as the pad, so is that 0.35 millimeters, maybe 0.4 millimeters. Like that. And the ground ones we could place a via. Like that. So let's see, we have those 3 resistors is the resistors for the RGB LED. So we could just keep them around here. That's fine. Like that. I did a mistake there. I had to grab this one. and a via to 3.3 volts. Like that. And we have those resistors here. We can place them over here. For the USB line. Could maybe route them on the top layer. See if that's possible. It is. And they should just be connected to ground. And this is also ground. Ground. And we can also put a via close to these ones. And of course the ESD diode. Like that. And then we need to route the traces for the LEDs. And we are on the bottom layer. Let's see where they belong. Around here. Like that, and then we have the two other ones up here. Let's try and find a way up there. That, and then we need the green color. maybe it was not so smart to go on that side. You can of course always place some vias, but it's prettier to do it without too many vias, I think, that are not needed. So we can just say route. And there's something we need to take care of. Like that. And there was something strange here. Like that. All right. Then we have a few capacitors here. One is for the ESD diode, for the USB line, and the final one, that's for the temperature and humidity sensor. That was C4. So we need to move that up here. So C3 needs to be down here. Like that. Then we can route ground out here. Place it here. Like that. So there's a connection here as well. Now we need to take care of the temperature and humidity sensor and the I2C pins. So SDA and SCL lines, they are on the other side there. I think that would make sense. Yeah, try to move it down a bit. And the main power is that on pin number 5. So we need to get this one close to pin number 5. This is here. And then we can connect that to 3.3 volts, and this one is ground. And this will be automatically connected to ground, and this one as well. Then we have our pull-up resistors. We can just say we need to connect that to 3.3 volts. This one to ground. And then we have our SDA line. And our SCL line. And that's our pull-up. Pull-up. That. SDA and SCL. And then we connect those to our sensor. Like that. And then we need to go into the ESP32. And then we need to get out of there. And we need to go to the bottom layer. And then we need to jump to the top layer again. We could move these traces, but I think we just place a V here. Jump to the top layer. Like that. Just keep that a bit away from the USB lines. Then jump to bottom layer. And then top layer. Like that. Then we have a ground trace there. I think everything is routed. 3.3 volts directly. A lot of grounds. Then we need to route the signals for our utility connector here. Let's try and see if we can make this fit. Can just go into a via here. And then the clock line could move this up a bit. Mosi. Maybe a bit more. That's chip select. And then the reset line, we should do that on the opposite layer. Like that. And I think we have all traces routed there. This, I would like to have this a bit thicker, this line. Should we make that 0.1 millimeter thick? Yeah. And we can place like 2 vias here. That's, and we have vias coming out here. Like that. Yeah, I think we are getting close to have everything routed. Maybe, yeah, they are also thick, the thickest, yeah. Let's try and save this and have a view in the theory viewer. Okay. So what we need to do now is to fill the ground layers. So we will just switch to a 1 millimeter grid again. And then we can place some filled zones. and we will do that on the top layer, inner one and bottom, and we will fill that with ground, and we would like the clearance to be 0.2 millimeters. Like that. Okay. And then we need to select the area we want to have it in. So we have one here, and then we just press B, and then it will automatically fill all we need. So we can try and just turn off those layers. Then we only have the bottom layer. We can see how everything looks from the bottom side. Then we can take and have a look on inner 2 layer. We need to fill in 3.3 volts on that. And this is the layer underneath our critical USB lines and all that. So it's also a solid fill. That's good. And then here we have the top layer. And we can see all the ground connections going into the ESP32 module. They are also being done automatically here. But we enable them all again, like that. And then we need to place another fill for the 3.3 volts. And we just say 3.3 volts, and we would need that on the inner 2 layer. And 0.2 millimeters. Okay. And then we define the area. Press B, and then we can have a look on that layer. So now we see that the 3.3 volts net has been applied to the inner 2 fill. 3.3 volts, and there's a via here coming in the 3.3 volts. So that's perfect. And now we see that there are like a distance here between the edge and the copper. We can make it a bit smaller. Right now it's 0.5 millimeters. So we can set, sorry, this was not this one, this was so the port setup here, and we need to go to design rules, constraints, and then we have copper to edge, and I will just make that 0.1 millimeter. And then we update it, press B, and then we have 0.1 millimeters to the edge. Now we see one more problem. If we enable the top layer here, then you can see that the ground are way too close to the USB lines. So we need to have at least 2 to 3 times the width of the signal line needs to be the clearance between the ground layer here. So we can also have a look in our rules for that net class for the USB lines. And let's have a look on the net classes. And what do we have here? The clearance. So we would like that to be 0.5 millimeters because the width of one track is 0.15 millimeters, and 3 times that's 0.45. And let's say okay. And then we can update that, and then you see it automatically makes a larger spacing here, so that we will have the correct impedance on our USB lines. And there are a couple of places I would like to place some vias, so we can just enable all tracks again, and then we can place a few vias or ground vias. Let's see if there's one we can copy. There's one here. Duplicate. And then we would like to have a point, so like that. And then you see there's an array here. We can just place a via. Couple of vias here. And there's also a place here. And we can just place some extra vias around. Just randomly put them in. Just to tie the nets together. That's it. Like that. And then we can update the board and see, okay, everything looks fine. And let's have a look in the 3D viewer. So one more thing that we should do was to align some of the silk screen. And have a look on the designators. If we can make something that looks nice, we can try and highlight those. And just hide these ones. See if we can do something that makes sense. So C5 is this one. Like that. put them on the other side here. Yeah, these resistors, I will move them away. And also the caps. Like that. Like that. Have a look here in the 3D viewer. Yeah, there's something it's not so pretty with the D1 there. U4 can get a bit closer. Like that. Apparently there's no designator for the USB connector. Let's see if we can see if something is wrong. We can show that. Okay, and that is J1 now. Like that. Let's put on some text. I have a YouTube symbol. Let's see if there's room for that. Maybe there's no room. Yeah, maybe there's only room on the bottom side for that. Flip. So we can just write place text. Should we make it a bit thicker, that line? ESP32-S3-MINI. That it's a small board, it's only 40 by 40 millimeters, and then we can say place footprint. I think there's a KiCad logo as well, a KiCad logo. Flip, remove that on the back side. Place some text. Powered by, made by. And our sponsor, PCBWay. Okay. And we will make that a bit bigger. Right. And we can flip that as well. And then we can move that in there. Something like that. Just keep that away from the mounting holes there. Yeah. Let's have a look on how it looks in the 3D view. And there's a few VS. Maybe move that one. Let's have a look on the other side. Maybe we should move that up a bit, then I think that's actually fine. Then we're free of the mounting holes down here. Like that. Like that. And then there was some mounting hole or a veer here. Just move that a bit away. And then there's one there by the end. Don't think that can be done better. Then save this. And then before making the Gerber data, we would like to make a inspection and to see if there's any design rule errors. So let's run the design rule checker and run the design rule check. Then we can also see if there are some unconnected traces that we need to take care of. So we see we have 21 errors and we have some warnings as well. So let's have a look on the unconnected items. So we have something here, missing connection between items, track, that's on a 5 volt track. Firewalls coming in there. There seems to be a trace there. Are we missing a track here? And we would also like to have this a bit thicker. That was 1 millimeter. And we need to check if we didn't make a trace on the backside for the firewalls. We didn't. So we just have to look at, try to close this one. And we need to have a look on the capacitor up there. On the top side. And place it here. Go to the bottom layer. And like that. And save. And then we can do another design rule trick and see if we lost one error. Yes, so we only have 20, so we have another one here. That's some ground pins. That's a ground pin here. We are missing a ground, so we need to place a via. And let's do another. So we only have 2 unconnected pins now. Pad number 6 on U number 3. So this is this one. Like that. An update. Tools. Inspect design rule check. Run design rule check again. Then we only have a missing connection there. That's the signal line. So let's see if we can route that. So we can close down the zones a bit, so they are not so annoying to look at. And let's try and route this signal. Just go out here. Place it here. And need to go over here. Like that. and then we can say inspect, design rule check again. And now we see there are no more unconnected nets, but we still have 17 errors. So we have some clearance violation net class. So yeah, of course that's a problem. We cannot have that clearance of 0.45 millimeters to ground in here, because these tracks or the pads themselves, they are too close. So that's the reason why we get these errors, but there is nothing that we really can do about that. So if we look at the zones again, then we can see that these pads, they are way closer than 0.45 millimeters, but yeah, there's simply nothing we can do about that. So that's why we get these errors here. And that's also the reason why we get this error here with the ground line. They are also too close, but we need to get ground to this this pad here, so there's nothing we can do about that either. And you can see all the red markers here, they are errors. But they are related to the USB connector and the way that this chip is designed. So we cannot get closer. We could just have a look again on the design rules and see if there are something else USB related. This is just USB related, all this stuff. And then we have some warnings that we have the sill screen is too close to the edge, but that's also fine. That will the manufacturer, they will take care of that. But then there's something here. Thermal relief connection to zone incomplete layer, front copper zone, minimum spoke count. Yeah, this means that there are only one spoke coming out. This is okay. This is this one. There's only one connection coming out to the ground, but there's not much we can do about that either. You can see these have two, but this only has one. But that's how it is. We could connect the pin number 9 to ground and then go in there and then to the poor, but that's not necessary. So I think we are done with the design. Let's have a look in the 3D viewer one more time. And the back side. Perfect. So I really hope that you enjoyed the session and you learned something. Please feel free to comment down in the comment section, and see you in the next one. Bye.